All right, we're talking about branching and looping, which is cool. And we can see from this diagram that when on line one, there'll be some statement and then a conditional. If b is less than 0, the Boolean expression is true, then we'll execute these lines underneath it and then move on to the next lines. But in example 2, if the Boolean is false, it skips over the lines within the brackets. It skips over the lines inside this function and goes to the next ones. In C, both if statements and while loops rely on the idea of Boolean expressions. And I don't know, are there any languages where that isn't true? I don't know. Oh, I'm dropping a lot of frames now. No, it seems fine. Here's a simple C program demonstrating an if statement. Include int main. Oh, it's not formatted. Integer b, print f, enter a value, scan f, placeholder, address operator. If b is less than 0, print the value is negative. New line. Oh, you're missing a slash for your new line. Return 0. All right, I don't think we'll do that one. We'll do the more complex one. This program accepts a number from the user. It then tests the number using an if statement to see if it's less than 0. If it is, the program prints a message. Otherwise, the program is silent. The b less than 0 portion of the program is the Boolean expression. George Boole invented this notion of, although I think I read something the day about a Russian who may have beaten him to the punch. But anyway, George Boole gets all the credit for this formal logic of it's quite interesting. Yeah, let's go look at it. What do we have but time, especially with everything shut down? How many pages are in this? Boolean logic developed by George Boole in the mid-1800s allows quite a few unexpected things to be mapped into bits and bytes. The great thing about Boolean logic is that once you get the hang of things, it's outrageously simple. Outrageously simple. It makes me angry how simple it is. Outrageous. This is the way we talk in the 20s. Everything is outrageously simple. A not gate has this crazy symbol here. Yellow triangle. An and gate has this blue semi-oval. An or gate looks like a bit like an arrowhead with a rounded tip. And a nor gate. What's the difference between the nor gate and the or gate? Oh, it's got a dot at the end. 3, 5, or 7 symbol gates that you need to learn about. Oh, and it was Claude Shannon who took George Boole's notions and put them into translated it into computer usage. But again, I read something saying that maybe there's a Russian guy who beat him to the punch. But in the English-speaking world, we give credit to Claude Shannon at Bell Labs for developing Boole's logic gates into a physical system. With these simple gates, you can build combinations that will implement any digital component you can imagine. These gates are going to seem a little dry here, incredibly simple, but we will incredibly simple, outrageously simple. I'm outraged at the simplicity of these gates. We will see some interesting combinations in the following sections that will make them a lot more inspiring. If you've not done so already, reading how bits and bytes work, be careful. It would be helpful before proceeding. Well, we're not going to do that. It will go down a rabbit hole we'll never come back from. Not gate. The simplest gate is called an inverter or a not gate. It takes one bit as an input and produces its output as the opposite. The logic table is 0, 1, 1, 0. 0 is not 1 and 1 is not 0. Is that the idea? The not gate has one input called A and one input called Q. Q is used for the output because if you used O, you would easily confuse it with 0. Yeah. So they decided to just call it Q, because, you just add a little tail and it's O. Why O? What was O for? Output? then A should be I for input. Oh my god, you guys, the Aussie is still falling in this Aussie yen short trade. What a good trade. Can you imagine if somebody had an idea of trading the Aussie yen short? What a good idea that would have been. The AND gate performs logical AND operations on two inputs A and B. Okay. So A and B. 0 and 0 is 0. So not true and true is not true. True and not true is not true. True and true is true. The idea behind an AND gate is if A and B are both 1, then Q should be 1. You can see that behavior in the logic table for the gate. The table row by row like this. Oh, like I did. If A is 0 and B is 0, Q is 0. If A and 0 and B is 1, Q is 0. You see, not true has predominance over truth. Interesting. Interesting in our day and age to consider that not truth is a little bit stronger than truth, sadly. If A is 1 and B is 0, Q is 0. And if A is 1 and B is 1, the OR gate lets anything through as long as one thing is true. If A is 1 or B is 1, or both are 1, then Q is 1. So if A is not true, B is not true, B is not true. Why would I be dropping a lot of frames again, guys? What is going on here? If A is not true, but B is true, then the output is true. A is true, but B is not true, it's still true because we just need OR. If they're both true, it's true. The NAND gate. Those are the basic gates. Now here are the more complex gates. The NAND and the NOR gate. These two gates are simply combinations of an AND and an OR gate with a NOT gate. If you include these two gates, then the count rises to 5. Here's the basic operation of NAND and NOR gates. You can see they're simply inversions of AND and OR gates. Inversions of an AND gate? So how does it work? Oh, is this, so a NOR gate? Let's start with NAND gate. NAND gate would say that truth has precedence. So if A is not true and B is not true, then Q is true. Oh no, it inverses it completely. So two wrongs make a right in an AND gate. A wrong and a right makes a right in an AND gate. A right and a wrong makes a right in an AND gate. And two rights make a wrong in the bizarro opposite world of NAND. And then in NOR, two falses make a true. False and true makes a false. Yeah, the opposite of what you get in an OR. True and false gives you a false, and two trues gives you a false. Yeah, so basically whatever happens in AND and OR, you just do the opposite in an AND and an OR. And then there's the exclusive OR or exclusive NOR gates. I think at one point in my life I understood this. I read the concept and sort of said, oh yeah, I really thought it through, and brain was working well at that time. And I got it. I just got what they were talking about. But can I say that I understand now? The idea behind an XOR gate is if either A or B is 1, but not both, Q is 1. The reason why XOR might not be included in a list of gates is because you can implement it easily using the original 3 gates listed. Oh, you can sort of create a construct of an exclusive OR gate. But the idea is it's one or the other, but not both. And then it's true. So it's exclusive OR gate. So false or false is false. And in the OR, that would have been true, right? False or false is no, false or false. Anyway. If you trial 4 different patterns for A and B and trace them through the circuit, you'll find that Q behaves like an XOR gate. Since there's a well-understood symbol for XOR gates, it's generally easier to think of XOR as a standard gate and using the same way as the circuit diagram. All right. Well, there is a point where this may become important. Exclusive or, exclusive nor. But I think for now, the important thing to remember is either A or B is true, not both. Q is true. Basically, when it's both, it's false because we need one to have exclusivity. All right, that's how I'm going to interpret it. Oh, I think we're getting out of our wheelhouse here. But this is good. I like Marshall Brain's stuff. Good job, Marshall Brain. He is definitely a brain. Is that an instance of biological destiny where you're destiny arising out of a patronymic? Okay, let's do this slightly more complicated example. And just change what. So we have an integer called b, and we're going to print enter a value, or a scanf that value using the integer placeholder, an address operator. Wait, that's ampersand. And then we have this conditional statement. If b is del less than 0, print value is negative. Turn 0 the non-error error. In this example, the else if and else. No else if and else. Oh, they're going on to another example. If the Boolean expression evaluates to C, then C executes a single line immediately following the statement. Boolean expression false, C skips a line or block statement. All right, well, let's just run this and try it out. Enter a value, make it a positive value. Oh, you know what? Let's alter this to give you feedback either way. Need I don't know. That's the way I'm doing. That's the way I'm doing it. Let's say else if. Oh, I'm just gonna say else. Value is not negative. It could be 0, in which case, yeah, I'm still recording there, bucko. I'll let you know when you can come in. Can you close my door, please? Thank you. These are the conditions under which we must exist. The value is not negative. Right? 2, 4, slow down. Not like that. All right, let's run that. Let's see how it goes. Oh, expected to do after this. Oh, yeah, so I missed my semicolon. Okay, enter value 7. Value is not negative. Now run again and say enter value, and we'll say -7. Value is negative. Aha. Now let's try the exception case. Not negative. All right. In this example, the else, if, and else sections evaluate for 0 and positive values as well. Let's see. Here's a more complicated Boolean expression. If x is the same as y and j is greater than k, z equals 1, or else q equals 10. The statement says if the value in variable x equals the value in variable y, and if the value in variable j is greater than the value in variable k, then set the variable, otherwise set the variable q to 10. Kind of a weird program. I don't know what purpose it would serve, but I think I get it. Do you get it, viewers? Do you understand what they're talking about? Notice that C uses double equal signs to test for equality. Yes. While it uses equal signs to assign a value to a variable. This is a perennial glitch with computer programs because we needed something to assign, and it sort of makes sense to say, hey, let this be equal to something else. But at the same time, we also have to say when something is the same as something else, and it's different. It's different to say something is the same as something else and to say that something is something else. Really, we should have used an entirely different symbol, but we're stuck with the double equals, or sometimes, as in JavaScript, the triple equals. Is it Python is triple equal? Anyway. C uses double equals to test for equality, while it uses equals to assign a value to a variable. The double ampersands in C represents a Boolean AND operation. Here are all the Boolean operators in C. Very important. Commit this to memory. Equality, double equals, less than sign. Greater than is the greater than sign. Less than and equals is less than equal sign. And greater than equals, greater than equal. Inequality is the exclamation mark, not equals. And double ampersands, or two pipes. Not is exclamation mark. So, yeah, know this. This is important. All that stuff. You'll find that while statements are just as easy to use as if statements. For example, while a is less than b, print a new line and the variable a equals a plus 1. This causes the two lines within braces to be executed repeatedly until a is greater than or equal to b. While statement in general works is illustrated to the right. I think it's they're talking about this graphic here. Say we set b equal to 1 while b is less than 2. Some stuff will happen, and then we increment b until that becomes false, and then it moves on. Clear as mud. Oh, LootBG has left me a spam link. Let's go. Let's check it out. My first spam link. Content warning. Oh, I got rickrolled by LootBG. That is awesome, buddy. I'm never gonna give you up. First person to chat in my thing here. I'm gonna be friends with you because that is awesome. Getting rickrolled. Let's tell you how I feel. Yeah. So how come I can't see that guy though? I show viewers and listen, I see me, but I don't see anybody else. Also, I probably shouldn't let people post links. I do that. Stop links. Show mod icons, show moderation actions, show messages caught by automod, show timestamp, deleted messages, chat. Emotes only, slow mo tasks. Manage moderation settings. Block hyperlinks. This makes sense. All right, is that all I have to do? Save it anywhere. All right, well, that was exciting. Still can't see the viewers, though. Show moderation actions. See, I don't even, like, it says show moderation actions, but what moderation actions? Ban timeout or mod user. Okay. Oh, well, Rickroll is not a bannable offense, not in my channel. Okay, so while statements, I get it, but let's do that because that sounds like kind of an interesting little program. Int main. Do is make a while loop. That. Boy, oh boy, I hope you can see my screen, or this has been a big giant waste of time. But what I see right now is just the title screen. I can't see my own screen. Big bug in Twitch Studio. Okay, so while it's the print %d and comma a plus 1. Right, that's incrementing a. Sort of a long-winded way, but that's all right. And we need to set the value of b. Let's say b is 5. Now, do I need to declare a? Can I run this? Let's just try running it. Oh, wait. Yeah, I know we need to declare a. So let's set a equal to 0. There we go. 0, 1, 2, 3, 4. A while loop. This causes 2 lines within braces to be executed repeatedly until a is greater. C also provides a do while structure. Ooh, let's do a do while. Wild and crazy C. A. Print enter value. Scanf %d %. I never look at punctuation very often, so I don't know where it is on the keyboard. I have to look at my keys to do it. If a, keep the following. Print value is true, capital T. True. Let's use punctuation. All right. Cool beans, cool sauce. All right, let's try this. Let's run it. Oh, extraneous bracket. Or where's my extraneous bracket? All right, enter a value. 4. The value is true. But that doesn't, that's silly. It's always going to be true. Why would they use that as an example of a do while? Print enter number, scanf. Silly. That's a silly example. That's never not going to be true. A for loop in C is simply a shorthand way of expressing a while statement. Oh, interesting. I'd never thought of for loops that way. There's shorthand while loops? Is that right? I guess. Suppose you have the following code in C, x equals 1, and while x is less than 10, blah, blah, blah. Increment x. X plus plus is the same way as saying x equals x plus 1. Yes, very important to know that. X plus plus is the same as saying x is the same as x plus 1. X is going to become x plus 1. And then x minus minus is a decrement. It's reducing it by 1. It's such a common thing for programmers to do that they invented a shorthand for it. You can convert this into a for loop as follows. For, and then there's 3 things you need to know. What you're starting at, how long you're going to do it for, and what you're changing each time. So for x is starting at 1, we're going to do this as long as x is less than 10, and we're going to add 1 to x each time, and then do a thing called blah, blah, blah every loop. Every time it goes through that loop for 10 times. The while loop contains an initialization step over here, x equals 1, a test step, do this while x is less than 10 or while something is true, and an increment step is placed inside the body of the function. The for loop lets you put all 3 of those parts onto one line, but you can put anything into those 3 parts. For example, suppose you have the following loop. A equals 1, B equals 6, and while A is less than B, increment A, and then print the placeholder of the A value. You can also do that with a for statement. So for A equals 1, equals 6. Oh, you can initialize multiple variables with a comma. Right, so that will produce a loop counting from 1 to 0, well, 1 to 7. Let's try it. Let's do it. Let's fall in love. Don't sing. For A is 1, 6. And I separate it with semicolon. I say that A must be less than B. By the way, good style. Spaces between that. I like that as much. It's supposed to be the style. Actually, maybe. Not sure. Not sure what the style guide mavens say about that. All right, we're going to increment this each time. Oh, and then I don't have to do a separate function body. I'm just printing each line, I guess. Printing each line. Okay. Print that. Oh, so many errors. Undeclared identifiers. Huh. Well, you lied to me. You lied to me. You can't just do it like that. I know that if I took this out of here, did that's gonna maybe work. No, no, it's saying they're undeclared. Why? Or the space here. Not the space. Equals 1, b equals 6. Space here. Now you still have to declare these variables. Like expected identifier or bracket. Okay. No. Yeah. Semicolon there. Put the semicolon on a separate line to silence this warning. Silence. For loop has empty body. No, it doesn't. Oh, because you put the semicolon there. There we go, 1 to 5. So I don't know. Is this an error? Is it a mistake on their part, or is this something you can actually do? Oh. Let's do this. Let's comment out my code. And let's just put that in and see what happens. Oh, it does. It does work. As long as you've declared these two variables first. And then it goes from 2 to 6. Interesting. Interesting. Do mine again. Different. They behave differently. Oh, interesting. Okay. Slightly confusing, but it is possible. The comma operator lets you separate several different statements in the initialization and increment sections of the for loop, but not in the test section. Initialization and increment sections. The test section is the middle part. It's the second of these statements separated by semicolon. Many C programmers like to pack a lot of information into a single line of C code, but a lot of people think it makes the code harder to understand, so they break it up. Yes, I would be one of those people. Equals versus equals in Boolean expressions. The equals sign, double equals, is a problem in C because every now and then you may forget and type just equals in Boolean expression. Yes, and if you're like me, you may even forget the difference between the two things sometimes. No, I wouldn't do that. This is an easy mistake to make, but to the compiler there's a very important difference. C will accept either equals and double equals in Boolean expression. The behavior of the program changes remarkably between the two, however. I've already seen an example of remarkable difference. You'd think that these programs, this one here and this one here, should roughly do the same thing, but they do not. They are different. Boolean expressions evaluate to integers in C, and integers can be used inside of Boolean expressions. The integer value is 0 in C is false, while any other integer value is true. So in my other program here, let's go back to it. Not just like any other guy. Let's run this. And I will say my value is 0. Aha, no statement. I have nothing to say because the statement is false. 0 is false. The following is legal in C. A is anything other than 0, the printf statement gets executed. In C, a statement like if A equals B means assign B to A, and test A for its Boolean value, right? Not what you would usually think, just reading it. Basically, you'd be saying if A is a value other than 0, if A becomes 0 after assignment, the if statement is false. Otherwise, it's true. The value of A changes in the process. This is not the intended behavior if you meant to type W equals. Although this feature is useful when used correctly, right? It's not a bug, it's a feature. So be careful with your equals and double equals usage. Excellent. So today we learned something about branching and looping.